The savings bank issues term deposits earning interest at the rate of 5% compounded semi-annually. Calculate the value of a 6,000 term deposit maturing at the end of 1 year. And so here, in order to answer this question, we're going to use this formula, which states that A is equal to P multiplied by 1 plus R over N, and all of this is raised to the power of N times T. Now, in this formula, A is equal to the amount of money accumulated after N years, including interest. Then we have P. P is the principal amount, and that's going to be 6,000. So P is equal to 6,000. And then we have R. R is the annual interest, which is 5%, or 5% written as a decimal is a 0.5. I'm sorry, 5% written as a decimal is a 0.05. So R is equal to 5% or 0.05. Next, we have N. N is the number of times that the interest is compounded per year. And we have here that it says it's compounded semi-annually. So that means that twice a year. So twice a year, right? So the number of times that the interest is compounded per year is going to be 2 times because it says that it's compounded semi-annually. So that means that N is equal to 2 because the number of times that the interest is compounded per year in this case is twice. So N is 2. Next, we have that T. Well, T is the time the money is invested for in years. And it says that calculate the value of a 6,000 term deposit maturing at the end of 1 year. So T in this case is equal to 1. So P is equal to 6,000, R is equal to 0.05, N is equal to 2, and T is equal to 1. And so using all those values, we're going to answer our question, and we're going to insert those values inside of this formula. So we have that A is equal to 6,000 because P is 6,000, right? And then we have 1 plus R. What is R? R is 0.05 all over N, and N is 2. And then we have multiplied by N, and then we have on the top, we have N times T. So there's going to be T. So it's going to be 2 times 1. This is N times T. So N times T. So it's going to be 2 times 1. So again, we have that P is equal to 6,000. R is equal to 0.05. N is equal to 2. N is equal to 2. And T is equal to 1. And we substitute those values in. Next, we divide. We say 0.05 divided by 2. That's 0.05 divided by 2 is equal to 0.025. Next, we say 2 times 1, and 2 times 1 is 2. Next, we add these two, right? So we have 1 plus 0.025. And when we add these two, we have 1.025. And so we have 1.025. So we have 6,000 multiplied by 1.025 raised to the power of 2. And when we do that, when we say 1.025 raised to the power of 2, we get 1.050625. So 1.025 squared is going to be equal to 1.050625. Next, we multiply these two. And when we multiply these two, we get 63. We get 6303.75. And so that means that the value of a 6,000 term deposit maturing at the end of 1 year is going to be $6,303.75. And that's our answer, $6,303.75. And that's our answer to this particular question.